The second disease, which caused by mutation in gene encoding protein channels, is cystic fibrosis. A defective gene causes the normal thin and slippery secretion of sweet and digestive tract become sticky and thick. The secretions plug up tubes, ducts, and passageways, especially in the lung and pancreas. A mutation in the cystic fibrosis membrane conductance regulator gene, CFTR, change the protein that regulates the movement of salt in and out of the cells. The result is thick and sticky mucus in the respiratory, digestive, and reproductive systems, as well as increased salt in sweet glands. Children need to inherit one copy of the gene from each parent in order to have the disease. If children inherit only one copy, they will be carriers and won't develop the condition. CFTR is a central regulator of salt and water transport across multiple epithelial cells. Normal airway epithelial cells, you can see the picture at the bottom, regulate sodium via epithelial sodium channel and chloride transport via CFTR in order to maintain an optimal periciliary liquid layer hay in order to support ciliary motion and to adequately hydrate the overlying mucus layer. In cystic fibrosis, epithelial cells missing CFTR and hyperabsorption of sodium and water is happen, which leading to formation of dehydrated mucus. This will cause defective mucociliary clearance, mucus obstruction, and superinfection. In cystic fibrosis, salt reabsorption from sweat is markedly abnormal. Reabsorption is driven by a large inward gradient for sodium which flows into the cell through epithelial sodium channels in the apical membrane. You can follow on above picture. The basolateral sodium pump then transports sodium out of the cells, which is not shown in this picture. Chloride is electrically attracted to sodium and follows it by flowing through CFTR channels in the apical membranes of the duct cells. The cell membrane has a low permeability to water, allowing reabsorption of salt and production of diluted sweat. In cystic fibrosis, CFTR is not present and sodium conductance also seems to be low, leading to hypothesis that CFTR activates sodium channel in sweat duct as well. The negative charge in the duct prevents further sodium absorption, and this will cause high salt content in cystic fibrosis sweat. You can see the description in 3 next slides. Complications of cystic fibrosis can affect the respiratory, digestive, and reproductive systems as well as other organs. Thick mucus in the lung and sinuses provides an ideal place for bacteria and fungi. They may have sinus infection, bronchitis, or pneumonia. Staphylococcus aureus, Haemophilus influenza, and Pseudomonas aeruginosa are the 3 most common organisms responsible for lung infection. The mucus can plug the pancreatic ducts, causing atrophy of exocrine glands, so digestive enzyme cannot secrete it or carry in digestive system, and proteins and fat-soluble vitamins malabsorption will happen. Almost all men with cystic fibrosis are infertile because the vas deferens tube is blocked with mucus or missing entirely.